a disk floating through space with a tiny sun.
Hey, I'm Fight the Flat Earth and welcome back to the channel that uses the boot of knowledge to curb stomp stupidity. And tonight we have round 2 of debating between Multiperson3141 and Why You Are an Idiot. Henceforth from here on to be called W because I'm not using that mouthful. Now, what do you guys think of my swanky new setup? Thank you to the Creaky Blinder for the channel art. And vMix is amazeballs. Everyone should stream with vMix because it's just incredible. So just before we get started, I've got a little thank you because I reached a massive milestone on my channel today, and absolutely I'm blown away because I passed 1 million views on my channel, and frankly that is, you know, I'm astounded. I never thought that would happen, and I want to say thank you to everybody that is constantly watching my channel and giving me feedback to help me get better, because I always appreciate feedback and I want to improve. And yeah, so thank you so much, guys. I'm coming up for 12,000 subscribers and I passed 1 million views, so thank you. I'm blown away. Next week I'm gonna have like a subscriber week. I'm gonna try and get some people involved in the videos, and I'm gonna do a live stream where I've got 3 flat earthers, and I'm going to get patrons and subscribers to come on, and they will get 10 minutes to choose one flat earther and ask them a question. And we'll just keep it going for as long as we can, because that sounds like a lot of fun, I think. And obviously with the new setup, it will all be amazing. So yeah, next week I'm going to have a week of saying thank you to you guys, and put out as much content as I can. It's hard putting out constant content, but I'm loving it. And just thank you. And because of you guys, I'm just going to keep doing it. But anyway, enough about me and saying thank you. But again, thank you. Tonight, again, we have Multiperson3141 and Why You Are an Idiot. If you didn't see last week's debate, I think both of them did okay for the debate because there wasn't any, it wasn't aggro, they weren't shouting at each other. I won't really say anything about Why You're an Idiot's proofs because I don't really think he has any. Multiperson3141 obviously on the right side, but he's an inexperienced new debater. I know he made some mistakes and people pointing out to him in the comments, but I also know that he's looked back and he's read those comments and he's ready for this round 2, and he says he's not going to make any of the mistakes again, and I've got high hopes for him because he's a very intelligent guy. Do you say you're a physics undergraduate?
Yes.
Yeah, so he's very, very smart. You have to be able to do that. So yeah, let's just get this going. You said you wanted to keep it to just 3 of your points today. Multiperson?
Yeah, because one thing I noticed is that my points were, I guess, deviating from what I know, and I want to avoid that. I want to be able to actually talk about something with confidence instead of going off on a tangent. But I also feel as though 5 points is a tad much, because if I have 3 points, then I have plenty of time to flesh out what I have this time around.
Okay. What we do then, I'll take a beat off of Simon and Dan's debate last night because that went really well. I'll let you take it in turns to have a point and talk about it, and then we can just move on, and then the other person can bring up a point. So do you want to go first? Multiperson, just bring up your first point. We'll talk about it, and then we'll see what Why You're an Idiot has to say.
Yeah, so it's only fair because I wanted him to go first last time.
Okay.
So before I...
Oh, your audio's cut out there. You there, Multiperson? Hello?
No, thank you.
Oh, wait, okay, I can hear you now. Why You're an Idiot?
I'll let you start.
Oh, I'm Sorry, I
I know nothing about religion anyways, so even if I had decided yes, it's pretty one-sided on your end.
Oh yeah, years of study compared to, I don't know. You said you haven't studied it, so you probably wouldn't know much. So I don't blame you. But yeah, let's get these 3 points across, and I'll see what comes up.
So
You can start.
before I actually begin with my first point, but before I begin with my first point, I want to actually point out some of the things that I mistakenly said last time, because I apparently said something that didn't make sense, which was kind of predictable, especially since many things that I attempted to talk about were some things that I have not fully studied. So first off, last time I said that coal is made of pure carbon. That is not true because I had confused coal with graphite. So my apologies on there. Coal is made from compressed plants, but I did let W get away with saying that there was a 10,000-mile coal seam last time. Now, I don't want to talk this time, but obviously I shouldn't have let that slide. The hotspot picture that W had sent last time displays an optical phenomenon. No second, I just couldn't come up with the term off the top of my head. Seismology is used to deduct the Earth's innards, not electromagnetic machines, like I mistakenly said last time. Oversea electrical cables exist, not oversea electrical cables. I made the mistake of saying that there were no such thing. And the last thing is that the Coriolis effect is actually not easily detectable, and a better example, rather than the drain example that I gave last time, would be to describe the offset by projectiles affected by the rotation of the Earth ever. So I just wanted to clear that up before I begin with my first point. So my first point has to do with the magnetosphere and aurora positions on Earth. So the Earth definitely has a magnetic sphere. We can prove it. We have compasses that work, that face north, and the Earth's surface magnetic strength is around 5 × 10⁻⁵ Teslas, which is relatively small, but definitely detectable. So one thing that the flat Earth model has a problem with is explaining how the magnetosphere actually works on that model. So the first image I'd like to bring up is called FE magnetic field, flat Earth magnetic field, just so that
let me just get that
the audience can see what I'm talking about.
1 second, I will just load that up for you. FE magnetic.
Oh, someone wants my mic turned down. Am I allowed?
I can turn you down a bit here. That's fine.
Sound fine to me.
I'll just take the edge off here. Right.
So
which one did you say?
So. FE magnetic field.
Okie dokie. Right. There we go.
So here is obviously a very simple diagram. This is the generally accepted flat Earth model with the poles of the theoretical magnetic field being presented here. So the North Pole is in the center because obviously, and the South Poles are at the edges. Now, when you're looking at this one-dimensionally, even there lies the problem because unfortunately, that is not actually how magnets work. So I believe, what is the next picture? The next picture is of FE 3D magnet, if you would like to bring that up. This, obviously, as it says, is not to scale. But you're looking at basically a three-dimensional version of what the magnetic field of the flat Earth would look like, with the edges of the Earth being south and the center being north. I haven't exactly gotten this on what the bottom of the flat Earth looks like, so I just drew it with dashed lines because I don't know what it could look like, and I haven't gotten any consensus.
Yeah, I don't blame you
on that.
I don't blame you.
The next picture is FE 3D flux. a model looks like a map. Oh, my bad. Okay, so these are models. The other picture I showed was a map. My apologies. So this picture is what predicted flux lines would be on a flat Earth, because flux lines never cross. They go out of north and into south. And the problem with this is that while this kind of, I guess, sort of looks like a magnetic field, it doesn't take into account the rest of the hidden Earth that we haven't uncovered yet. So the next picture is disk magnet flux. And in this picture is what an actual disk magnet looks like. Now, as I said, I do not know what the bottom of the flat Earth looks like, but the flux lines go out of north and into south, but on a disk magnet, go into the bottom as opposed to into the sides, like the flat Earth model would suggest. Now, this is obviously a problem because magnets don't work like this, and you can actually test this by placing a disk magnet into, I believe, a jar of, I want to say it's not glyphosate and it's not glucose, because that's weed killer and sugar respectively. I can't remember the name of the chemical, but it's essentially this clear liquid that is very, very dense. And when you surround a disk magnet with iron filings and put it into such a jar, you can actually see exactly how the magnetic field acts around such a disk object. And second to last picture is sphere magnet flux, which is essentially how a sphere magnet works. And you can do the test. You can take a sphere magnet, surround it in iron filings, and then put it in a jar of whatever that chemical name is that I can't remember the name of. And you get this sort of pattern. And this pattern makes much more sense than the flat Earth pattern that I showed before, because it takes into account the entirety of the body, because it's not just one section of the planet that is magnetic. We can prove this because the crust isn't very magnetic. It's only deep down into the Earth. So the flux lines once again go out of north into south and then through the planet, which is what we observe. And the last one is kind of related to the magnetosphere. It's related to charged particles. So that would be FE 3D aurora, if you want to bring that up. And it's essentially a diagram of how auroras would work on a flat Earth. So the first thing you see is that, because we know and we've proven that the reason auroras happen is because oxygen atoms and other different atoms in the sky are being ionized, or is it ionized? It might be charged. One of the two, by the sun. And the sun essentially charges these particles, and as the electrons in these atoms fall from an excited energy level to the ground state, they actually release photons, which creates the beautiful lights that we see in the sky. But on the flat Earth model, the moon and the sun actually revolve around each other. And if auroras are caused by the sun, then the pattern should actually be more centered around the sun as opposed to the entirety. And that's what I had to say about the magnetosphere.
Okay. You're done? Just let me know when you're done.
I'm done. Glycerin. Okay.
Right.
Yeah. Someone pointed out it's called glycerin. Thank you.
Okay. Well, here's the thing with what you were saying. It sounds very good. It sounds very well studied. The issue is you're using DITRH's model. That comes from DITRH. He believes the magnetic center and all this stuff. I don't, because unfortunately I don't have enough evidence to go on. So I'm just going to be honest. I don't know. And I'm okay with saying that. Now, is the Earth magnetized? Yes, that is a fact. No one can deny that. You can dig into the Earth. It is magnetized to an extent. Now, is there a magnetic center? Probably, maybe. But I don't know. Sorry, I don't, I don't have a ship. I don't have, the money to get on a plane and go travel everywhere and, check all this shit out. Sorry, I just don't. So now with my magnetic Earth, it's completely different. Okay, I use it as a reference to the sun and the moon because they got to be staying up there somehow. Because if we're on the flat Earth model, they have to be staying up there somehow. That's just a fact.
Of course.
Now, there's a clock. It's called a levitating clock. Okay. Basically, what happens is you put like a little ball on it. Okay, and it slowly just circles around and floats there. Okay, using simple magnetics. Okay, so the theory would be is the sun and moon are floating just based off the magnetics all over this flat Earth, not on just the center. The whole thing has to be somewhat magnetic in some way, shape, or form because it has to circle around it, and then on top of that, it does other things. Now, I want you to think about this just simply. If we can create something like a levitating clock, anyone can look this up on YouTube. You guys in the chat, yeah, look it up right now. Just put levitating clock, you'll see it. If us, the human race, can do something as simple as this, what can God do? We're talking about, a being smarter than us, just hands down, smarter than us. So it really wouldn't be that hard if we're inside of, a simple cage. If we are inside of a simple, glass casing, whatever you want to call it, we're inside a cage. It's not hard to do that. He could do the same thing we're doing in a bigger form. And then the sun and moon just rotate slowly around. Now, as for the aurora borealis, I disagree with you on that. Sorry, I do. Now, this is me going to scripture because this is what I love. This is what I do. Okay.
I can tell.
In Revelation 4, basically, it talks about how when God sits above the throne, above the dome. Okay. Now, around the throne, he talks about an emerald, basically an emerald rainbow. And that sounds very interesting because the aurora borealis is an emerald color. That's just the reality of it. It's an emerald color. So it's like, okay, what's going on here? And it goes into a little more detail. And basically, aurora borealis is the power of my God literally seeping through the dome. And that sounds crazy. I know. But I'm telling you this right now. That's what it is. Now, as for the levitating clock, God can pretty much mimic the sun and moon just like that if he wants to. We can do it. He's bigger than us. He can do it too. As for the aurora borealis, that's for your choice to believe what I'm saying or not. Sorry, I don't believe it's because of, some sun particles or anything like that. Just don't. Oh my God. Sorry, my phone. But yeah, I don't believe the aurora borealis has anything to do with the sun or anything like that. I believe it's the power of my God. Because if I was to ask you a simple question, where the heck does the power of magnetics come from? Yeah, you can do an experiment, you could charge it, all this stuff, and do all these things to make it work. But it's like, where is this actual power coming from? There really is no answer other than either it's randomly just coming out of nowhere or God, and everyone makes a choice at the end anyway. Either way. So if you want to know how the magnetics work on my flat Earth, look at the levitating clock. That's to give you an idea of how mine works, not DRTRH. That's his model. Okay,
So
I'm done.
I'm not basing the flat Earth model off of DI whatever TH's model. I'm basing flat Earth off of the general consensus that has come to believe. So there are many flaws with the way that you say magnetism works, because you say that we don't know, or you don't know how magnetism is actually true. So first off,
no, where does the power of magnetism come from? Where does the power come from? Like even the electric charge that we get in energy, where does that come from? Because it's not us that's doing it.
Yeah,
Okay,
W.
go.
Try not to
So-
interrupt when he's in the middle of.
Sorry.
That's cool. All right.
So the problem with your
Continue.
aurora model is, first of all, auroras are not always emerald colors. They actually range on the entire visible light spectrum. It's just that the green is the most prominent because of the fact that yellow and green are the colors that you generally get from an oxygen atom being ionized and dropping from higher energy levels to its ground state. The magnetic field of the sun is about 1 Gauss, I believe, which is like twice the Earth's magnetic field strength. Moon has a range of different magnetic field strength that goes from 20 to 110 microtesla. So the moon is actually either weaker or stronger than the Earth, depending on different times. So the problem with that is that even if your model suggests that auroras are created from his emerald whatever, and I'm trying not to go off of scripture because I know nothing about scripture, then what you're getting is aurora around different areas. Because if the moon and the sun are in different strengths, then you're going to get different strengths of aurora in different locations. So the auroras around the sun should be much stronger, but that's not what we see. We actually tend to see auroras at nighttime. And another problem with your model is that what you're saying about the magnetic clock, again, a magnetic clock requires 2 different magnets to function. You need 1 magnet at the base and 1 magnet to actually make it levitate. So if you're looking at the sun and the moon and the Earth, that means that the Earth must be a magnet and the sun and moon must be magnets that are facing the same polarity towards the Earth. And if that was the case, then that means either north or south would be in the general equator of flat Earth, and that the sun and moon would be facing downward in the same direction, which is, of course, not what we see, because the moon faces the same side towards Earth, but the sun does not do that. The sun is known to rotate. You just can't see it because you'd blind yourself if you looked at it without a telescope or some other optical device. So the odds of the Earth having a specific pole at the equator on a flat Earth with the sun facing opposite polarity, same polarity, with the moon facing same polarity, and them being at the same height despite their different masses and different field strengths, especially the moon's varying field strength, it just does not fit.
Okay. All right. Now, here's where my issue came up. Like when I first heard you, how much did you say, or joules did you say the sun had? Am I correct? You said something about joules.
It's not a joule measurement. It's 1 Gauss.
1 Gauss. There we go. 1 Gauss. Okay. How the heck are you gonna? No. I really want to know this. How the heck can you prove that? Can you touch the sun? Have you been on the sun? Like, that's a very big assumption you're making. Like, how can you prove it's 1 Gauss? Like, I would never make that assumption. I don't even know the size of the sun. I just say, okay, it's up there. It's not as big. And I leave it at that. I'm not going to waste my time trying to measure it. I'm not on it. So how the heck do you know it's 1 Gauss? What makes you know that? Like, you understand what I'm saying? Like, you threw out an assumption that I was like, okay. And then also you said the moon also, has some type of Gauss or some type of, whatever you want to call it, magnetic effect. And I'm just like, how can you prove that? How can you yourself prove the numbers that you just told me? You've never been to the moon, ever, whatsoever. So it's like, these are 2 assumptions that you're making already with inside the spectrum of what you're saying. Now, if you don't want to believe the aurora borealis stuff, okay, be my guest. I'm using scripture. But guess what? When it comes to that, what you just said, the assumptions you made, sorry, not buying it. I'm not buying it. Sorry, you haven't been there. You don't have a piece of it. But go on, explain. I want to see what answer you have for this.
I think the problem is that you don't understand what an assumption is. An assumption would be something, it's essentially a prediction that you make given previous instances. The sun being one Gauss and the moon fluctuating in magnetic field strength is not an assumption, it's a measurement, and there's actually various ways we can measure the sun and moon's magnetosphere without actually being there. So the sun, and this is a very clever method, is when the sun is ejecting coronal mass, like it has coronal mass ejections. You've seen it. The sun has various flares so strong that it can knock out different electrical grids on planet Earth because of how strong these solar flares and coronal mass ejections are. But the thing is that the coronal mass ejections actually follow that magnetosphere. So what we can do is, after analyzing the shape and the size of the shock of the mass ejection, we can actually essentially, I don't want to say draw because that's an oversimplification, but we can essentially see where the magnetosphere is. And then once we take measurements of the particles that are coming towards Earth from those mass ejections, we can then use those particle strengths to actually figure out just how much force the Earth's magnetosphere has in those specific areas. And as for the moon is a little bit more difficult because of the fact that it's not only is its magnetic field strength varying, but it's also facing the same direction. So it's really hard to, I guess, get a different angle on the moon. Essentially, how that works is you were looking at a spectropolarimeter, which can be installed on telescopes and has been installed on multiple scopes. And what this detection does is it actually is able to detect the magnetic fields using various instruments within the telescopic piece. So it's really hard to explain, but there's pieces of the telescope that can tell you the exact strength of a magnet. And I forget how it works because I haven't looked at a spectropolarimeter in a long time, but that's the basic idea. So to sum that up, the sun has a measurable and definitive magnet, and the moon has a measurable and fluctuating field strength. So it still stands, the idea that you're not going to get that perfect system where the sun and the moon are rotating above the Earth in a way where they're practically the same height and they have no issues whatsoever.
Okay. Well, besides the fact that a lot of things you say are kind of beliefs, as much as you want to say they're fact, they're kind of beliefs. Let's go with your premise. Let's go with your premise that what you're saying is true. Okay. Wouldn't it be easier? Wouldn't it be easier to get, an actual reading from a close moon and a close sun that's close by, rather than something that's 250,000 miles away to 93 or 92 million miles away? Like, you think you're going to get a reading from that far away when I say the sun and moon is 11 to 40 miles? Remember, we're going off the assumption that what you're saying is true. Wouldn't it just be easier to get something from 11 to 40 miles? A reading from that, especially a magnetic reading close by, just like in my model, there's some type of prediction there. It's easier. Like it just would. It would be easier. That is a fact. Okay. And then the readings could.
I just want to clarify. Did you just say there's prediction on your model?
No. I'm saying that it would be easier if the sun and moon were close by with what he's saying. Because you got to understand, what he's saying is a bunch of beliefs. But I'm telling it to him. Like, let's take it as fact. What you're saying is fact. Even though I know it's a belief, let's take it as fact. It would make more sense if the sun and moon were closer to get those magnetic readings rather than really far away, which I don't know how the hell you're going to get a reading from 93 million miles away. How? How? When on my model
First of
makes
all,
more sense. It's close by.
Let
It's
Multiperson
rotating.
respond to how you would get a reading from 93 million miles away, because I want to hear that.
I want to hear this. I want to hear this. Go on.
So, believe it or not, it's actually more difficult to measure a magnetic field when it's closer, depending on its size. So when you're looking at the sun and the moon, which are huge, even on a flat Earth model, you are getting a measurement that is 1 Gauss and 21 to whatever microteslas respectively for the sun and the moon. But the problem is that when you're closer to a field strength of such a size, you're actually inside those fields, and it's very difficult to detect a field that you're inside. For example, the Earth has a magnetic field, and we can measure it, but it's actually easier to measure the magnetic field strength from a place that isn't Earth, which is why there's been several satellites, and for example, the ISS has done measurements on the field strength of Earth from outside of the planet because it's easier that way. So since the sun is so ridiculously strong in magnetic field strength, and the moon is ridiculously weak, the issue that you end up having is that when you're looking at a flat Earth, you have a giant 1 Gauss magnetic field right there, along with a 21 microtesla magnetic field, and nothing's happening between the sun and the moon. You can say that the way it works is that it's balanced and that they rotate around and float above the Earth, but that can't be possible if those magnetic field strengths are true, which they are because we've measured them with the spectropolarimeter.
Okay, you done? I just want to know. Just let me know.
Yep.
Okay. All right. Now, you said they're getting the readings from the ISS. Ooh, this is going to be a good one. This is going to be good. Okay. Now I got to ask you this question. Okay. One, you said the fact of how high the ISS is. The fact of the matter is, this is what NASA says, okay? This isn't me. This isn't someone else. This is literally what NASA says. The temperatures fluctuate, and they go between what? 2,600 degrees in Fahrenheit, and I think 1,000 or 1,200 Celsius, something like that. All right. So that's high temperature. Now, if there was no one on it, even then, it wouldn't work. It would be lit, and it would basically be melting. And no, I'm not joking. It would basically be melting. Because you can look this up on John Thor's channel. He has a YouTube channel, John Thor, and his second video, his second to last video, I think it's like 20 minutes or 30-minute part. He literally shows what it's like when you heat something up at 2,000 something degrees and what it looks like. It is red hot. I mean, boiling, melting. It is melting. So you're saying these guys got a reading out of the ISS that is supposedly, 2,000 and some type of fluctuation temperature that is 2,600 degrees Fahrenheit. No, one, they would die. Two, the ISS would be melting. That's just a fact, because that's what they say. Remember, I'm not going based off, what other people are saying. This is what they say. Now, if you want to take it as fact, okay, be my guest. But if you want to say it's, nothing but freezing up there, then okay. What do you think it is? What do you think's happening? You think I'm going to trust the ISS readings? No, sorry. I'd rather use the Earth down here. Let's use the magnetics of the Earth, and let's do what we can with that. But yeah, okay, your turn. You can go.
I have one more thing I'd like to say about my respective point.
Mm-hmm.
You are saying that you would rather believe that the temperature of the sun is an incorrect measurement rather than believing that the sun is just far away and that's why the temperature does not literally melt and vaporize the ISS.
No, I'm saying there's a standard temperature for it. Now, can it change? Yeah, on God's order, but definitely, not just some random 93 million mile away sun. Like, it's not going to work like that. Sorry, it just isn't.
Okay, right. I think we've demonstrated what we need to on that point. So, why you're an idiot? Would you like to bring up an evidence for the flat Earth?
Ooh, here we
Yeah,
go.
sure. Okay. All right. So on your ball model, we have, I think, if I'm correct, the Earth is rotating, I think, 1,000 miles an hour or something like that, and moving at 66 or 67,000 miles. Something along those lines. Forgive me if I get the numbers wrong, but it's going very fast. Okay. Now, if it was going that fast, basically all the atmosphere would be spinning in pretty much one direction. Okay. Now, here's the issue with that. Let's say I get on a plane. Okay. If there's 1,000-mile winds up there. Okay. If there's 1,000-mile winds up there, the plane would literally have to fly one direction, and not just one plane. Every single plane on Earth would have to fly one direction because of that pressure. Because I could show you, there's a video. I remember looking up 40-mile winds, 50-mile winds almost made a plane crash. Just 40, 50-mile winds almost made a plane crash, and it's on video. So it's like, okay, 40 to 50-mile winds are doing that, almost making a plane crash. Okay, so what can 1,000-mile winds do? It's insane. And then on top of that, we have planes going in every direction. So it doesn't make sense on your model. It doesn't. All planes would have to fly in one direction. Every single one. That's not what we see. We see planes flying in every direction. Craig, calm down. Calm down. Calm down. I could see your heart beating.
It's not my debate. I'm trying so hard. There's so much.
I know. Hold it in.
I
Hold it
understand.
in.
Multi-person, please.
I'm getting there. Okay, so I'm sorry. This is just really funny for some reason. Tell me, have you ever heard of the term relativity?
Yes, I have heard of the term relativity.
Okay, do you know what it is?
Tell me.
Relativity is essentially the idea that you can't get an exact measurement unless you have a reference point, hence the term relative. Because say you are in a car and you're driving at 50 miles an hour and there's someone standing on the sidewalk. You're driving 50 miles an hour, you see them go by at 50 miles an hour. So are they moving 50 miles or are you moving 50 miles an hour? The answer is that both of you are correct. Even though you may think that you're moving 50 miles an hour, it's because you are basing your reference point off of the Earth. So when you're looking at the Earth and you're driving in a car, you're going 50 miles an hour. But if the Earth wasn't there and you're just in a car floating through space at 50 miles an hour, who's moving? You are the person. The answer is that both of you are correct, which is the whole point of Lorentz transforms, is you're supposed to be able to transfer from one reference point to another. But when you're saying that there's 1,000-mile-an-hour winds, you're forgetting
Yes, there should
that
be.
you
Around there. It doesn't have to be perfect, but around there.
You aren't relating the winds to the Earth because the atmosphere is the same piece of the Earth. The atmosphere moves with the Earth. So if you're standing and you're rotating at whatever miles an hour and the Earth is rotating at something miles an hour and the atmosphere is rotating at that miles an hour, you aren't going to feel anything because everything is rotating, and therefore relative to the Earth or the atmosphere, you are not moving. But the Earth relative to the sun is rotating. So when you say 1,000-mile-an-hour winds, yes, the wind is 1,000 miles an hour compared to the sun, but it is not actually moving at 1,000 miles an hour because the atmosphere is part of the Earth.
Okay. So now let's take your car reference that you just said, because you said if you were in a car, etc. Okay, now let's do something real simple with this car reference that you globeheads love to do. You globeheads love to be like, oh, if I'm driving 100 miles an hour, blah, 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 do you feel anything? Of course not. I feel a little bit of it, but not much. Yeah, until I open the window. Until I open the window and that wind hits me, I feel it. I definitely feel it. Now, the car is a container. Whether people want to believe it or not, it is a container. So on your model, we should be feeling, 1,000-mile winds. That's what we should be feeling it, unless there's a container on top of it. So there's already an issue right there. Even if you say, oh, it's moving with the earth, okay, it doesn't matter. We should still be feeling 1,000-mile winds. That's just a fact. And guess what? You would need a container to pretty much stop it from blowing us away and killing us. So let me ask you this question.
So
How's that going to happen unless you're on a flat earth model with a container, with a dome? How are you going to do that?
You just tried to use relativity to disprove relativity. So let me explain your car example. When you're in the car, there's air in the car, obviously. And yes, you're correct in thinking that the car is a container. The car is containing the air, which is also moving at whatever speed the car is moving. So you're in the car, and the car is moving miles an hour. So the air in the car is also moving 50 miles an hour. It's the same reason why if you have a tennis ball in the car and you throw it up, you can still catch it, because relative to you, the ball is not moving, but relative to the ground outside, the ball is going up the height you threw it, as well as going the 50 miles an hour that the car is moving. So when you open the window, you're actually essentially releasing the container, because all the wind in the car, or all the air in the car, is going 50 miles an hour along with you, but the air outside the car is moving past you at 50 miles an hour. So what you feel there is actually air relative to the earth standing still and hitting you in the face. So when
at 1,000 miles an hour.
No, at 50 miles an hour, because
Hello?
you're talking about relative to the earth.
Okay. Yeah, but the earth doesn't move 50 miles an hour. It moves supposedly like 900 something to 1,000. Everyone has a different number, but it's usually somewhere around there. So you want to say 50-mile winds? Please be my guest. I'm pretty sure the human race can take that. Even 100-mile winds, the human race can barely take it. They struggle. There's a video online I just saw like a few days ago. Like some guy, he's in like 100-mile winds and he can barely walk forward. And you're gonna tell me 1,000-mile winds? Sorry, not buying it. Sorry, I'm just not buying it. 1,000? No,
So
no.
We
need a container. We would need a container. That's just a fact. Or else we die.
I think you missed the point that there wouldn't be 1,000-mile-an-hour winds because the Earth has a relative rotational speed of 1,000 miles per hour, even though that's not how you measure rotational speed. So I
think our example for this. Now, this is not the same, but it's analogous to what's going on the Earth. If you have a water bottle that's filled halfway with water, and you start swirling the water bottle in a circle, the water in the water bottle is what it looks to you sticking to the bottom of the bottle. That's centripetal force, which is not the same as gravity. It's essentially analogous to what happened with gravity, is because you're having something moving, but everything on it is moving. So if you were, I don't know, say you're an ant and you're swimming in the water of the water in the bottle, it's going to look like everything around you is rotating. But to the person swinging the bottle, it looks like you're insane because you're clearly moving really fast. But to the ant, he doesn't feel anything. He's just swimming in water, probably dying and suffocating. It's the same idea, just a different force. You have the entire planet moving, but the atmosphere is with it and you're moving with it. That's why we do not feel 1,000-mile-an-hour winds. But that doesn't mean that the rotation of the Earth does not affect the winds, because obviously as the atmosphere gets thinner and thinner, higher and higher up you go, it's going to have essentially a lag time to the gravity because it's g m1 m2 over r squared. So as you get farther, the force gets weaker. So the winds on the atmosphere on the outside of the planet is actually going to lag behind, and that is the Coriolis effect.
Yeah. Okay. All right. I hear you. I hear you. I understand. Okay, but I how do I say this? I find it funny that I just find it funny that when I give an answer, I can literally shorten it down and simplify it and try and make it as quick as possible. But when you answer, it really has to be a long explanation because you have to add in all these factors while mine is so simplified. God, and in my head, I'm just thinking, God is so simple. It's not that hard. Oh my God. But all right, let's move on to another question. I have a question to ask. Okay. Or do you want to ask?
You,
do you want to answer your turn? I think it's your turn, right?
Turn, so
Yeah.
Okay, so my next point is, I gotta pull it up because I closed it like a moron. Yes, Gegenschein. A fancy word for something that's actually very simple to describe. So I'm going to explain it in two ways. One, I'm going to explain it mathematically, which I know you aren't a fan of math, but I'm also going to explain it in a way that you can understand. So first, we're going to explain it mathematically. Gegenschein is an example of when you take Maxwell's equations, which essentially predict electromagnetic propagation, and you solve it for diffuse particles that are a bit larger than their respective wavelengths. The answers that you get is actually going to be essentially two lobes of refraction. So you're going to get light that scatters in small angles from its direct beam, or you're going to get light that directly backscatters back to the source of light. So you essentially get if you've ever seen those artist depictions of a black hole with the jet streams, that's basically what it is, but with light. So you have some sort of electromagnetic radiation going to some sort of dense field, and then you have it refractals in small angles and going the direction that it was going, or you have it directly bouncing back straight to the source of light. So the reason that this works on a globe Earth and not a flat Earth is because the sun actually does this when it shines light on interstellar objects, particularly space dust, which is actually the Gegenschein that I'm about to talk about. So the sun is going to shine light onto the interstellar dust. The light is going to shine onto the space dust. I'm just calling it space dust for simplicity. And then you're going to have it refract in that direction. And then you're going to have it directly reflect back to the source of light in a small angle. So you have essentially, it's kind of like a mirror. You have like a flashlight or something pointing at a mirror, and it's going to bounce back at the mirror, only it's slightly different because it's refraction and reflection at the same time, and it's never mind. So basically, on a flat Earth, you're going to get what is essentially a small beam of backscatter, because the light is going to face up towards the dome or whatever you think it is, towards the interstellar dust, and then face backwards, and then go straight to the Earth, effectively create light similar to what we see or what we see on the flat Earth model. The problem is that that's not how it works, because backscatter actually encompasses the entirety of the planet because of how big the sun is. So on a round Earth, not quite yet. I want to bring up the pictures once I get to the simplistic way of expressing it. So you have the 2D model, you're getting a spotlight of backscatter. And on the 3-dimensional model, what's actually happening is that the backscatter reflects back to the sun in an angle so big that the entire Earth is encompassed by this backscatter, which is actually measurable in certain observatories, and we can measure the backscatter and figure out exactly where the sun is when it's nighttime. We can figure out where the sun is behind the Earth. So the easy way of explaining that is if you've ever taken a beam of light shining into a container of, I guess, water and flour. What's going to happen is that light is going to bounce off of all of the little particles and create a beam forward and a beam backwards. That beam backwards is known as backscatter. The beam back towards the light source is backscatter. On the end, let me make sure I'm referencing the right pictures here. FE backscatter is the first one I'd like to bring up. You have the sun 11 to 40 miles away, and you have the light shining from the sun to whatever is causing the backscatter, which is measurable. And what happens is you get the two lobes, the lobe that goes forward and the lobe that goes back towards the light source and onto the Earth, which essentially creates, as you can see on this diagram or whatever the proper scientific word for it is, you get a spotlight. So that spotlight is something that we should observe if the sun was 40 to 11 miles away, and the interstellar space dust it really doesn't matter how far away it is, because it still should only be a spotlight if the sun is that far away. Unfortunately, that is not what we see. The backscatter that we end up getting actually encompasses the whole Earth. So if you'd like to bring up our scatter, which is essentially a not to scale round Earth version of backscatter, which is what we observe. So you have the Earth there and the sun there, and the sun is shining light on the interstellar space, whatever. And then
sorry, which was the one
you get now? You have it up. Wait, what?
Right, okay.
Did you bring up the wrong one?
That's the one I've had up. Sorry, I don't have any of.
Oh, okay.
I should have had that one.
They're
up
very
to start
similar
with.
in name.
I'm
Okay.
sorry. That's the one I should have had to start with.
It's fine. This is the flat Earth model, in which the sun is 11 to 40 miles away, and you get a light shining onto the interstellar space dust. You get two lobes, one going forwards, one back scattering back towards the Earth, and you get a spotlight. So now if you bring up the round Earth version, you have the tiny little Earth as the blue dot, and then you have the sun on the side. Again, none of this is just, then I'd have to take up a document that's like bigger than any computer I can own. You have the sun shining onto the interstellar space dust. It's creating two lobes, one towards the same direction it came from, and then one back towards the sun. But the sun is so ridiculously large and the Earth is so ridiculously small that this backscatter actually encompasses the entirety of the planet. And that is what we call Gagan shine. And if you ever want to see Gagan shine, you just have to go to a not very light polluted area in which you can see the Milky Way, because that is an example of Gagan shine.
Wow, this was this was a long explanation. This was a long explanation. Honestly, very, very, very interesting what you're saying. Okay. So I think I get what you're saying. Basically, the sun is there. It reflects off what you want to call the space dust, and then it creates a beam back. Okay. I get that point. I get that simple concept. Okay. Now, let's just be real with this. Okay. Wouldn't it make more sense? What you're saying? If we were in a closed system, just like you said, because you mentioned container. You mentioned container yourself. Now, it'd be more simple, like you said, container. Now, with the sun inside, beaming its light on the glass dome above us. Now, on top of that, there's water above it, so that'll add even more to it, just like you said. Correct, you said water and flour, I think, or something like that. Forgive me if I'm wrong, but yes, you said something like that. So that would reflect even more. Now, on top of that, you said we don't see a spotlight from the sun, which is a big mistake on your part. We actually do see a spotlight of the sun. We can see two, honestly, but three total. Basically, what happens is when the atmospheric density kind of clears up, the sun literally reflects The sun literally reflects off the dome, off the glass dome. So you can get that same spotlight that you're talking about. And then, of course, we have what we call a sundog, which looks like 3 suns, but it's not. Now, you can follow this in one of my videos where you can watch it. They both go down when it was setting. The sun was setting. They both were going down at the same time, or basically away at the same time. And as the bigger one got smaller, so did the smaller one get small. And this happens every once in a while when the atmosphere clears up enough and it's close enough. And I believe that's when we talk about the Tropic of Cancer, Tropic of Capricorn, the equator. The more out it is closer to the dome, the higher chance of it showing its reflection. So that's what you're seeing when you're talking about, what's it called? Gegenschein? Yeah, if I'm correct, Gegenschein that you were talking about? Yeah, that's what you're seeing. It's not space dust, because you would have to prove space. Sorry, I don't see it. I haven't had anyone prove to me space. I have more evidence for the dome. I have a rocket hitting the dome. Not just one, several. If I'm correct, I think like 114 or something like that. 14 rockets like that are dated and estimated to have hit the dome, each one at different times. I guess they were trying to figure out which one's getting closer to the, closer to the center and how far it is. So it's a position of, well, space is real. So this is space dust. Yeah, it could just be regular dust, just from the Earth, and it could be the reflection of the dome causing it. It's really more simple. Okay, go.
Once again, you are making the mistake of assuming that if something is simpler, then it should be true. Occam's razor is an example of this, but not in the way that you think. Because Occam's razor is essentially a philosophical way of saying that whatever requires the least amount of assumptions must be true. The problem with using Occam's razor, though, is that you actually have to have measurable evidence of what you're saying in order to get a proper answer that has the least assumptions. So when you're looking at the facts, we know that the Earth has a magnetic field. We know that the sun is a certain distance away. We know their magnetic field strength. We know how fast the winds go and exactly how fast they will go depending on the rotation of the Earth. We know all this. So the reason that Occam's razor works is because if we say that the Earth is round, then we do not have to make as many assumptions. But with flat Earth, you have to make the assumption that the sun is 11 to 40 miles away, which, by the way, is like a flight distance away. So you're saying that you could fly into the sun, and then you could fly into the moon.
I believe people have hit the sun and died. Like, I'm not joking. I believe some of these planes
okay,
have...
citation fucking
And
needed.
where is your evidence for this?
Sorry.
Oh, no, I'm sorry. I think they burned up and died. I know, this sounds crazy, right? Sounds crazy. But I'm telling you, this because some planes go missing, and it's like, where the heck are they? Either in the ocean, or because you got to say, everyone assumes the sun is 93 million miles away. So a pilot's flying by, oh, the sun's 93 million miles away. Hits it. There. Why not? Why can't it happen?
Okay, right. Man, that's getting its own video. Wow. Okay, right. It's your turn to bring up a point again, W. Right, and this time, rather than trying to have negative evidence for the globe, can you provide some positive evidence that we live on a flat Earth?
Oh, that we live. Okay. All right. Okay. Here, let me ask you this question.
Did you forget what you were talking about? What?
No. When it comes to this is about trust. Now, let me ask this question. If you were born in the time of what I would say Germany or, Hitler and all this stuff, okay, with Nazis, would you trust a Nazi? No, I want you to be honest with me. Just be honest with me. Would you trust a Nazi?
The relevance of this information, please?
Let's be careful with lines of questioning like that.
I know, but just answer that simple question, and then I'll explain why. I'll explain why I'm saying it. I just want to know, would you actually trust a Nazi? Just say yes or no. It's okay.
It depends.
Okay, let's assume he was a killer. Not like, not like some regular person. A killer, killer Nazis. Not like just like, oh, I support the Nazi regime. No. Someone who was killed. Would you
Again,
trust
I'm
them?
failing to see the relevance. But again, just because they're a killer
Just
doesn't mean
please say
you
yes
should
or no. It's okay. I'm not here to bash you or anything like that. We're having this discussion right now. I just want a yes or no answer.
You can answer with no so that you can move on with your point. So can you please just move on with your point?
Okay. Well, here. Anyone who's looked into this knows that the Nazis are partially, I don't know if all of them, but a portion of Nazis are pretty much in charge of NASA. That's a fact. You can look through the history books.
Okay,
There's tons of Nazis that come here.
Stop talking. Give me a second. Where is your evidence that NASA is run by Nazis?
Oh, Werner von Braun. He was a Nazi. And then I think they took in 100 Nazi scientists, something like that, somewhere along those lines. And I think from the CIA it was James Hendrick or something like that.
Okay.
Forgive me if I forget the name, but yeah. Werner von Braun, yeah.
One sec, right, sorry. I really want to move away from just mentioning Nazis at all. So let's not do that again. What I think you're referring to is the fact that a lot of German scientists came to the United States after the Second World War. All right. So I'm going to ask you to disregard that as an evidence because I just don't want to talk about Nazis on my channel. So could you please bring up a different evidence?
Okay. All right. I'll bring up a different one. Still, I want to know if you would trust them. But either way, I'll bring up a different one. Okay. Here. Let's assume, because right now we're running on 20-something% atmosphere. Okay. Anyone who's done their research knows that the past had more atmosphere. Okay. Now I'm going to ask you this question. Where did the atmosphere go within these few thousand years?
May I know what you mean by more specifically?
Okay, here, I'll give an example. So, I'm not sure why this is, but basically what happens is, one, for the first part, the animals are bigger in the past. I'm pretty sure, I think I said this before, where there was an armadillo, basically the size of a small car. There's a crocodile, probably about 3 times the size of a regular one. It could literally fit a regular crocodile in its mouth. There's a penguin, 5 feet tall, found in the middle of a desert. In the middle of a desert, not just that, whales too. But these animals are huge. So in order to be that big, you need a totally different environment. And this is very easily explained with more atmosphere, more atmospheric pressure, more CO2 pressure also. And this has been pretty much tested, where they got a few plants and they pretty much put them in a contained environment. And it grew so huge they had to basically get stilts for it just to hold it up, because it was breathing in, it breathed in basically everything it needed. So the same concept could be applied to animals. More atmosphere, bigger, stronger, faster. So basically, I want to know,
hold on a second.
Where did this atmosphere go? We are smaller.
I want to know why the flat Earth is a better example of a thicker atmosphere in the past than now.
Oh, you want to know why?
I think I know where he's going with this.
Oh, you sure you want to hear this?
Right. His evidence is that there used to be more air pressure than there is now, and he's about to tell you why. Everybody in the audience, please make sure you have some kind of facepalm protection ready. W, go ahead. Why was there more atmosphere before than there is now?
Okay. The reason there was more atmosphere in the past and why we have a pressure gradient, Craig, is because Yggdrasil was on the Earth before it got cut down. Now, this sounds crazy. I don't know if you know what Yggdrasil is? Multi-purpose, you know what Yggdrasil is?
I
Can you hear
honestly
me?
didn't hear what you said.
Oh, you didn't hear me?
All right.
Okay.
Let me clarify. Let me to just repeat it for everybody. W's evidence of a flat Earth here is that there used to be more air pressure than there is now due to animals being bigger, etc., etc. And the reason there isn't such a high pressure now and that we have a pressure gradient is that a magic tree called Yggdrasil was cut down by the giants.
It's not a magic tree. You
But
keep saying magic, and it's
question,
like,
have to do with round or flat? I want to
what
know
happened?
why. I want to know how this works on a flat Earth and not a round Earth, because that is the point of this debate here.
Yes, I know. One, besides the fact that Bob, the science guy, you know, one of your guys, one of the bar guys, he already proved that you could have a pressure gradient in a container. So I could literally just say that. And he has a video showing it. He kind of did it for us, which I found funny. But I like to stick to what, you know, I say. Okay. Now, the thing is, okay, here. Yggdrasil was basically, before it got cut down, there was a giant tree in the middle of the earth. It's probably about 100 miles high, maybe more, but I'm just going to give an estimate, about 100 miles high. Okay. It got cut down during the War of Ragnarok, which sounds crazy, but yes, during the War of Ragnarok, when the giants were on the earth and they were alive, and pretty much they caused the issue. They cut it down. And that's one of the reasons we are smaller. Now, what is my evidence for what I'm saying? What is my evidence? I understand. One, I have giant bodies all over the place, giant footprints. This is all on my channel, okay? Giant footprints. I have the stumps of Yggdrasil. I have the thousands of miles of coal, which I saw your comment where you said no, it's not 10,000 miles. It's like, yes, it is. It's in my video. I left it there.
Which
All the
video is it?
information is there.
W, which video is it?
Huh?
And I'll put it up. Which video is it? And I'll put it up on the screen for people to see.
It's on it's the last one I made about you.
Oh,
Part
right.
two.
Okay, right. Bear with me,
Yeah.
and I'll get that up so everyone can see with the giant stumps
Oh,
of
I
Yggdrasil.
actually got one of my I forgot one of my two. I forgot my whatever. I'll just present them when I start my next point.
Well, basically what happens is if you have Yggdrasil, okay, on the earth, not just that, if you remove like pretty much like probably like 80% of the water because you know the flood, you remove that, basically you would have pretty much probably like 90 to 95, maybe even 100% air pressure. Just hands down, you would. Probably close to 100, if not. Because you know, a tree that big expelling oxygen for us to breathe, yeah, it's going to do the trick. Why we're bigger, why we're stronger, why we're this. And then when you cut it down, basically you cut it down and then you add the flood into that. Because right after Ragnarok, the flood happened. You add the flood into that. Guess what? You lose what? You lose most of your air pressure. We're running on like 20% air pressure. That's what we're breathing in, 20% of what we had before. So basically, we're weaker, not as smart, dumber. Like we're worse. We're worse. We are worse. We're devolving.
Let me just get that to the right bit.
Okay,
I'll show
hold on.
people the pictures.
So
yeah, please post it, Craig.
I think you're straying from the point here. I want you to answer directly with no tangents why Yggdrasil can exist on a flat Earth and not a round Earth. That is the specific I'm trying to get from you.
Because it would eventually, we got to understand, if, let's assume the pressure gradient is where it ends, Yggdrasil would not be so high. It would not be so big. And no, I'm not joking. Because if I want to, I can literally say the tree's 10,000 miles long. But I don't think that. Based off my evidence, I don't think that. But I can literally say, hey, look, this thing was 10,000 miles. So let's assume the tree was just, what, 100, 200 miles high? Okay? With the pressure gradient we have now, the tree would eventually die. it would just eventually die because there's not enough air pressure or atmosphere up there. Okay, on your model, on your ball earth model, it would eventually die.
How so?
Now, and then also, you got to explain, like, how the hell do you get, besides the 10,000 miles, there's several of these. I think I told you before, there's several of these on the earth. How do you, where did they come from? How do you explain it? Because if you say trees or something like that, like they all got bunched up together, yeah, that could happen. But we literally have trees buried in the earth turned to coal, and they're all separated from each other. Like pretty much, probably like 90, maybe 95% of the time, they're all separated from each other. They all went off in their own direction. So it's like, okay, so where did this long seam come from? Where did this long seam come from? There has to be an explanation for it. And the only one I have for it is, hey, Yggdrasil got cut down, the roots got buried in the flood, turned to coal, and we find human body parts, we find bells, we find shoes, we find stuff in there that's human. And this is a fact. This is.
So I just want to clarify for the audience here that your evidence of the flat Earth here, your positive evidence for the flat Earth is that there isn't a massive tree reaching up to the dome, and that some mountains and stuff look like roots, and that the not magic, but this massive tree couldn't have existed on the round Earth. You're saying it could only exist
it could never, because in your model, everything is the way it is now. There's no way it could exist here.
Right.
It died. It would die.
So
I know.
Do you not think that there's a possibility that there never was a big tree?
Well, you got to explain several things. You'd have to explain several things to me. Okay, one, what are the stumps? How did basically these plateaus that things people call plateaus? There are several of these all over the earth.
Okay, so which one was Yggdrasil? Why is there multiple?
No, these are the roots. Yggdrasil would be in the center, which would basically either be the North Pole or Meru.
Okay, but that's not roots. You're showing people pictures of a stump and comparing it to a mountain. So in what way would that be a root?
Okay, now imagine this is a root that extends out towards the center. And when it gets cut, okay, imagine it getting cut. Like in Naruto, Momoshiki, blah, 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 the fight. Yeah, just like that in the Naruto show, I'm pretty sure you all saw it just like that. Same thing, same concept. Okay, now imagine that piece of root in the ground, okay, that extends out for thousands of miles. It has to extend out for a few thousand miles, some probably shorter, some probably longer. But now, here's the question. What are those thousands of miles of coal in the ground? Because that's what it would turn to. It would turn to coal. So now, on your model, I want an explanation, a really good explanation for why there's 10,000, if not more in other places, seams of coals. And they're like 200 to 300 feet thick. They're thick. They're not. Because we've all been in like a 12-foot pool before. Well, not all of us, but most people have been in like 12-foot pools. Add what? How much more to that? It's huge. So how do you do that on your model? My model works perfectly fine. Okay, we're in a contained system.
I'd like Multiperson to just respond to two bits of that. First off, what are these plateaus?
Yeah, I want to see
plateau. And I'm expert in scientology or seismology, so I apologize.
You broke up there. You just start that again.
I'm no expert in seismology, geology, earth science, anything like that. But from what I remember, and this makes perfect sense if you actually, believe in tectonic plates, is the fact that magma deep inside the earth essentially pressurizes the surface, but since the surface is extremely strong, the magma can't actually, puncture through the rock. So what ends up happening is you get this giant pressure column that causes a column of rock to raise and form a plateau. And the reason it looks so specific like that is because the base is where a small amount of magma leaks, which creates that strange tree-looking pattern around it. I think I already know what the second thing you were going to ask is. I think that's how
about the coal and everything that he's going on about.
Yes. Thanks to several people who have pointed sources out to me, I actually know the scientific reason behind it. And the reasoning is because, and you probably think the Earth is only a couple thousand years old, but we've carbon dated, we've done many things to actually prove that the Earth is much older. And a long time ago, in a period known as the Carniferous period, there are many particular plants, ferns particularly, that essentially died, went into the ground, and pressurized and became coal. But the reason that we know it's specifically ferns and why it specifically came from this period is because A, we've carbon dated the coal to actually figure out exactly where what period of time it came from, and B, we were able to figure out it was ferns because, as you've said, there have been fossils. Now I know about any human fossils because I've never heard of any scientific document that stated that, but there have been fern fossils.
Hold on, what was that last part?
Yeah, you
kind of broke up.
Yeah, you dropped out with the word ferns there, I think.
Yeah, sorry, my internet's terrible. We've found fern fossils within these coal streaks, which, by the way, there is no 10,000 mile long coal streak, so I don't know where you're getting that information.
Hold on. Give me a second.
Ooh, is he going to provide a citation?
Can I do this? Can I do this real quick?
Citation? What? Oh my gosh, is this the first? This is great.
Let's see if I can find this bad boy. Just give me a second.
There's something. I love this chat.
Me too.
Hold on. Do you still have the video up? Do you still have the video up?
Yeah.
Craig?
Yeah. Yes. Where do you want me to go to it?
Hold on. Hold on. Give me a second. Yeah, just go to the video real quick.
Yeah.
Unfortunately, I don't want to take forever to find this. Okay. Okay, hold on. Yeah, I thought that was me.
Booking.com, you can find a house, a car, and even a bubble.
Hey, I had to say
But what happens then?
I don't know why I went Irish. Shut that.
Oh, why is that going to a different thing? Right, let me get the.
Hold on.
Displaying the wrong thing right now. Sorry.
Booking.com.
What the heck is this? I put it in my video.
There we go. So, why you are an idiot thinks we live in a dome?
Don't we all?
Right, where do you want me to go in this?
Okay, it'd be 640. Yes.
640.
Yes. Sorry, took a while to find. Oh, God. Yeah. You could just pause it right there.
Do you need me to play it or?
You can either pause it or you can play it, but
Okay, well,
I prefer to just say.
I already see the problem here. You're confusing a 10,000 mile coal seam with a 10,000 square mile coal reserve. The difference is that one is length and one is area. You're confusing it with the actual length of this coal seam. What it's talking about is how much physical area in the earth it's taking up.
Yeah, and then when you get a picture of it, you actually, take a look at it, from above, how they show it, it actually extends out just like a tree, just like a root trunk. It extends out. It's not like there's a pot over here, there's a point over here, there's a point over here. No. This thing extends out for miles and miles and miles. A long way. And it's on the video. You can probably play it and they'll probably show it to you. But this thing extends out super far. So guess what? I want to know how the hell that got there. I want to know. The only explanation I see right now are the roots. The roots got cut. They got buried. Now, if you have another explanation, that seems is good enough. Is good enough. Yeah, sure. I'll add it into my account. But the fact that you're saying millions or billions of years ago, or the certain period wherever exactly the dinosaurs were, yeah, sorry. There's only a few thousand years of actual, historical documented history. And then on top of that, carbon dating, oh God, Kent Hovind destroyed that shit. Carbon dating, potassium argon dating, lead 204, lead 206. He just destroyed it. It doesn't work. Even the people who created carbon dating say it has flaws. They admit, hey, look, this thing has flaws. Here, I'll give you an example. There was a baby mammoth called Dima. I think one part was like 9,000, another part was like 10,000, and another part was like 22,000 or something like that. The numbers were scattered everywhere. And this doesn't just happen once, this happens all the time. If I remember correctly, I think it was a recently killed penguin, was 1,300 years old. It was recently killed. Recently. It recently died. And it carbon dated 1,300? No. Sorry, the dating methods don't work. They just don't. And that's pretty much a fact. I've looked through this a ton. So basically, we're at the point where all we have is historical documents that people, write down. And since I'm the religious guy, unfortunately, it comes with the package. When you become religious, you have to look at the dates and you have to see what people are saying, and then you have to come up with your own conclusion. And trust me, when you actually come up with your own conclusion, you realize only a few thousand years have passed. So your whole theory on the ferns millions of years ago, yeah, not going to work. But tell me.
I want to say one last thing before I move on to my final point, because first of all, you unintentionally lied by saying that there's a 10,000 mile coal seam, when in reality it's just 100 by 100 miles of area that takes up the earth. And another thing you're forgetting is that you say it looks exactly like roots, but something that you're forgetting is that plants can only grow within a specific area. So for example, if you have some sort of dandelion, like one of the tuft dandelions, and you blow on it and it spreads the seeds everywhere, those seeds are going to grow plants near the original source of the plant. So the plants actually spread in branches similar to roots do, because that's just how seeds of plants end up spreading. Now, I don't know everything. I don't know everything about biology. I'm no biologist. You'd have to probably call up Professor Stick, because he is brilliant in explaining stuff like that in carbon dating.
Oh God, that guy! Oh my God, I already did a video on him.
Yeah, I'm aware.
Yeah,
and I've seen your video. It's quite beautiful. But that's all I really want to say, because I'm not exactly qualified to talk about it. So I just wanted to move on to my final point, which is probably my It's the least researched I have out of the three, but I definitely have plenty of evidence to back it. Although before I do that, I was going to ask if you could put up the Maxwell distribution PDF for a moment, as well as the interstellar backscatter PDF, because those go along with my Gagan Design point, and I forgot to bring those PDFs up when I was talking about them. They're just scientific abstracts and stuff like that on exactly what happens with how backscatter is calculated, along with how big and shine is measured. You can read it if you want. I'll send it in Discord if you need it, but let's be honest, I don't really think you're going to read it.
Yeah, I'll put all the links to the different PDFs in the description, and people can read them if they want to.
So my final point has to do with supernovas, particularly a very special supernova that happened in, I believe, the year 1987. There is a special little supernova that was detected. It was magnitude 3, and it's known as supernova. Oh, sorry, I hiccuped there. Supernova 1987A. This supernova was unfortunately too far away to see with the naked eye, but it was visible with basic telescopes. So we know it's visible, and therefore on the flat Earth, that means that the supernova, or whatever you would consider it to be, is above the plane of the Earth, which makes sense in that case. However, supernovas aren't just pretty little lights. They are giant explosions of many different elements and particles. One of those particles being neutrinos, which are, needless to say, peculiar little pieces of matter that don't act the way you'd expect. Neutrinos are actually very negligible matter, meaning that they don't react much with matter and can actually pass through things. Similar to how light particles can pass through glass, even though that's a solid object. Only it's different because neutrinos don't get absorbed at all. They just pass through everything. Kind of ghost-like, but not exactly ghost-like. Now here's the thing. There's many neutrino detection observatories, and neutrino observatories are actually directional, which means that when it detects neutrinos, it will actually tell you the direction in which they came from. So there were 3 at the same exact time that we were able to see the supernova with telescopes, which should make sense because neutrinos travel at the same speed as photons because they're basically the same thing, some form of electromagnetic radiation. And 3 different observatories in 3 different locations of the planet detected various neutrino levels. Kamioka Observatory, Haida, Japan, detected 11 neutrinos. Irvine, Michigan, Brookhaven Detector, Ohio, USA, found 8 neutrinos. And Baksan Neutrino Observatory in Russia found 5 neutrinos. All nearly simultaneously and nearly at the same time that the supernova was visible to telescopes all around the world, or all over the world in your case. Here's the thing. The observatories, which by the way are not government run, I do want to stress that, these non-government run observatories actually did the neutrino from downward, meaning that the neutrinos passed through the Earth and found vectors, which makes theoretical sense. I want to not mix up theoretical and hypothetical because they have 2 very different meanings in science. But these theoretical particles passed through the bottom of the Earth and reached the observatories from there, which is contradictory to what happened, because what we saw is the supernova with telescopes. So this means that the supernova should be above the plane of Earth. However, the neutrino observatories suggested otherwise and suggested that the supernova would be below the Earth on a flat Earth. So if you would like to bring up supernova conundrum is what I named the file. And essentially, in this diagram that's about to pop up any second now, is you have the terribly drawn supernovas on either side of the flat plane of Earth. You have the green arrows, which indicate the direction of the supernova based on telescope observations. And then you have the brown arrows, which are the neutrino observations by their 3 respective observatories. So obviously, on a flat Earth, this makes this doesn't make sense on a flat Earth, because obviously a supernova cannot simultaneously, a supernova specifically cannot be simultaneously in 2 different places. So if you'd like to bring up supernova fix, which is the not to scale round Earth version, is since the Earth is round, these 3 observatories on different areas of the round planet. So all of their directional neutrino observations came from the same direction as the telescopic observations, which makes sense because that means that the neutrinos pass through the Earth and reach the observatories at the same time that telescopes were able to pick up the supernova visually.
Okay. Just let me know. You gotta let me know when you're done, man.
If you'd also, I am done, but if
I'll answer your question.
I'm gonna remember your real name, Craig. If you'd like to bring up the PDF for supernova detection and have the audience read that while W is explaining his side.
Let me know when you're done.
I am done.
Okay. All right. So right here's where the issue comes in. It was the 1980s, right? Okay. So we have a 1980s. They look in the sky. They look in the sky. They see an explosion happen. Okay. They see some type of explosion. Something happened. Okay. They see it, and I'm pretty sure many other people probably saw it too. Because usually when one person sees it, there's usually a ton more. Okay. Now, does that prove it was a supernova? No. What they saw looked like an explosion to them in the sky. Now, what could it be? No idea. I don't know. I mean, I could come up with many theories in my head about what it was or what they saw. But to say it's a supernova and that it's in outer space, a little bit of an assumption. It's more like there was an explosion in the sky and, we don't know what to make of it. That's pretty much what happened. Now, if you believe what was falling from the sky came down and went through the Earth or something, that's another assumption. That's another guess. That'd be another guess because we're talking about different people on different parts of the Earth looking and seeing the same thing. Now, that would work better on the flat Earth model, but let's assume it's on your model. Okay? How is that going to happen? If one person's on one part of the Earth and another person's on another part and another person's on another part, how are they all going to see the same thing if the supernova should be happening in one section? Maybe 2 of them might see it, but all three of them would have to be in the same area of the Earth, basically. Because if you're saying 3 people on different parts of on different parts of your globe saw it, on different parts of your globe saw it. Unless they're all in the same section, not doable. And then on top of that, it's just what looks like an explosion. What do I make of that? I can't make anything of it. All I know is an explosion happened. After that, the rest is guesswork to me.
Are you done?
No, you can go now. You can go.
Even if it was just an explosion in the sky, you're failing to explain the reasoning why we see something, therefore it should be above the flat Earth, but we detect something simultaneously that came from it, which means that it should be on the other plane of Earth. Explain why either this is okay or this is wrong.
How is it not okay? It's on my flat Earth. Everything's contained in a contained system.
What do you mean?
So,
How is that not
like,
okay? You have
no. What I mean is, it's okay. It's okay in a contained system. So let's say it's on the light side of the Earth where the sun is, and the supernova happens there. Okay? Everyone on that side is going to see it. And possibly some people, even on the dark side, might be able to see it. Maybe not all, but maybe even some with a good telescope. Because remember, this place is enclosed and not that far away. So getting a real good telescope, you can see pretty darn far. So seeing it isn't really that hard of an issue. It's really not. It's very easy, actually. On my model, it is extremely easy. Unless there's atmospheric density, stuff like that in the way. But you're talking about a big, huge explosion that happened in the sky. It'd be very easy to see.
Okay.
Especially if it's at night. If it's at night, even more.
One, you're assuming the explosion came and went. Supernovas are so ridiculously large that they don't just come and go. In fact, this exact supernova can still be seen by telescopes that you can buy at a store. So if you want to, you could go outside, point it towards the Large Magellanic Cloud or Magellanic Cloud, whatever it's pronounced, and find the supernova with your telescope. So it's still there because of how large it is. You're still failing to explain why the supernova was visually seen in one direction at the same time that 3 observatories detected neutrinos from this source at the exact same time from the opposite direction.
When it comes to the whole detecting neutrino thing, I leave that up in question. I'm not 100% sure on that. When it comes to an explosion, it's kind of hard to hide that. So I'm just going to assume it's real. That's just the reality of it. As for the neutrinos part, not 100% sure on that. But you're asking me, how can we see it on a flat Earth? How can we see a big explosion in the sky on a flat Earth? I mean, come on. Just look, the picture's right there. If I put a big explosion somewhere in here in the sky, tons of people will see it. Tons of people, especially the people with telescopes. Tons of people will see it. But let's go to your model. Let's say someone's in America, and then another person's in Australia, and then another person's, somewhere else. Like, only so many of them are going to see it. Only so many of them are going to see it. Mm-hmm. And then the rest is up to conjecture. On mine, it's easier. An explosion happens, like, pretty much most of the Earth should be able to see it. Especially if you're saying it's as big as it is. If you're saying it's as big as it is, then pretty much almost the whole Earth saw it. Now, I wasn't there, so I can't 100% verify this, but let's assume it's true. Then it works better on my model than it does on yours. It's way easier.
You can go outside and see it yourself.
Yeah. And what about it? You want me to look at where an explosion happened? Okay. Then what? Then what's going to happen once I look at it? Okay, there's looks like probably some lights of some kind probably. And then I'm just going to be like, okay. Then what? Exactly what I'm saying. This is like the Big Bang. Oh, an explosion happened. We don't know what made it happen, but we believe in it. Now, you're saying an explosion happened. I believe you. Now, after that, what else am I going to go through? You're going to tell me, oh, we can still see some of the effects of it. Okay. Then what? What does this prove? What does this prove? An explosion happened in the sky. It can work on both models. It can work on both models.
I think we'll leave that point there because I feel like you've completely missed the point, and Multiperson, I think he's explained it sufficiently, and I'm surprised you're not getting it. So
I get what you're saying, but I'm simplifying it. I'm just simplifying it down. That's what I do.
How are you simplifying it?
Yeah, right. So
I'm saying photons came from one direction, while neutrinos came from the other, and that only makes sense on a round model, and you've failed to explain why it could work on a flat model or why it doesn't work at all. So I just want to move on at this point.
No, because I told you, I don't believe in your neutrino thing. neutrino thing? I don't believe in it. I'm not
And there's
100% sure on that.
number one.
Personal
How can I
incredulity is
prove?
personal
No, because
incredulity
we're
isn't
talking
really
about
evidence, W.
no, because we're talking about an explosion that happened in space somewhere, and you're telling me it's somehow, probably billions or millions of miles away or something like that. Because you know how they are. It's millions of miles away. Somehow, magically came here and just landed on Earth. Oh, and we were able to. No.
Okay, right.
No, it would go off somewhere in some other direction.
Right,
Makes no sense.
Stop. Right. Obviously, we've missed the entire point there. So we're going to get on to the final point, which is your turn. Do you have another positive? Well, you haven't really given any positive. Do you have a positive evidence for the flat Earth, like a picture or a video or some math that works out some evidence of a flat Earth of any kind?
No math. No math. I told you I like to keep it simple. I mean, besides the fact that this is what I like to keep it to, the physical evidence. I don't like to keep it to anything else but that. Because once we start going into other things, it becomes maybe not.
Being detected in various cylinders, observatories all around the world is not physical evidence.
Oh no, the fact that they're looking at stuff in the sky, but how can you yourself prove it's space? Because you can get a telescope yourself, and you can look and be like, oh man, this is nice. What's happening up there? I wonder. Look, but to say it's automatically outer space and you can go for millions and billions of miles, that's a belief.
Well,
that's a very religious belief.
We have plenty of evidence to show that's the case, but the thing here is that I've given you two opportunities to present positive evidence for the flat Earth, and on both accounts you failed, because your first time you basically said, I don't think that can work on the globe model, therefore flat, and that's not positive evidence. And then the second time you misunderstood the difference between square miles and miles, and you showed us a picture of some plateaued mountains and said therefore giant tree. Personally, I don't think either of those things class as evidence of a flat Earth. So for the third and final time, do you have any positive evidence for the flat Earth?
Well, which one do you want to go through? The glass dome?
Yeah,
the rockets?
Do you have evidence of? Do you have evidence of the dome? Let's go with that.
Exciting, please.
Let's go with the dome, right?
Okay.
I'll keep evidence of the dome.
Okay, I'll keep it simple. I'm pretty sure everyone knows this about the rockets hitting the dome. Okay. All right. Now there are several of these throughout. Now you can do your back history of the ones that were fired beforehand or the ones fired now, which are pretty much on YouTube. Anyone can see them. So we give an estimate of what? If I'm correct, it went 70 miles before it hit the dome, something like that. Okay. Now, when you actually look into the back history of the other missiles that were shot, you get around the same time, but then you also get ones that take a lot longer. Like if I'm correct, one took 140 or 50 seconds to hit the dome. Basically, it's spreading out. Basically, what they're doing is they're trying to figure out more of the center of the place. Like how far does this go, how big it is, etc. Now, if you're going to say the video is completely fake, okay, be my guest, but it's there for everyone to see. And pretty much anyone with enough money and enough, time and all this on their hands can do it. It's been done several times already.
So do you want me to present a video for people to see?
Yeah, you could. I'll just send you the simple one, the basic one.
Yep, send me the video and I'll get it loaded up for people.
You could just copy and paste it.
Okay.
I sent it.
What did you send it on Discord?
Oh no, I sent it on the chat.
Ah, right. Did I miss it? Can you just put it in Discord for me?
Yeah, hold on.
Okay, thank you.
the chill part of the stream where we we all get to introduce each other.
No, wrong one. Sorry, I'm in the wrong box. There we go.
I'm supposed to have a religious debate soon, hopefully.
Oh, that would be good to see. Different.
Yeah, I saw a Cosmic Skeptic debate some guy, and I'm like, this guy's doing a terrible job. Like, I could have answered like all those questions so easily.
And let me just put the YouTube up for people to see, which is there. Right, where do you want me to go in this video?
You could just watch the whole thing. You could just watch the whole thing.
4, 3, 2, 1.
I don't think I've got audio on for that. Cheers, play, no, I do. I'll turn that down. Oh. Displaying the wrong screen, Craig. Dope. I'll just speed it up a bit because we want to see the bit where it apparently hits the dome. Okay, there we go. Multi-person, do you have any response to that?
I'm kind of confused at what I'm looking at because all it really looks like is that it's either breaking the sound barrier or breaking the atmosphere, and I can't really tell the difference with video alone.
Yeah, it's okay.
But
it's at the end of the day.
What I can confirm is that it's not hitting a glass dome, because if it was, A, the rocket would have been crumpled by the pure force, and B, the glass would have shattered, and that's obviously not what we see. Again, you never specified specific type of glass, you never specified flint glass or whatever, and you never...
Yeah, that's the thing. I don't know. I don't know what type of glass. If I knew the type of glass, trust me, I'd tell you. I'd be like, oh, it's made of this, because, you know, I saw it, I touched it. No. I can see it from a distance. I can see the glass, I can see the dome and everything. Every day when I walk outside. I can see it every day when I walk outside. I can't tell you what type of glass it's made of. That, I wish I could tell. Sorry, I don't, you know, they pretty much blocked us off from going there. So, I mean, we can if everyone was to group up.
You can see and touch?
What?
Are you saying you only believe in stuff that you can see and that you can touch?
Yes. So basically, I can see the dome. It's not like some, because you understand, we're talking about what, 70 miles? This one is 70. This video is 70 miles. If we go towards the center, it'd probably be 150, maybe 200, something along those lines.
I've got to ask a question. I'm sorry. You only believe in things you can see and touch. When did you see and touch God?
Oh,
I was gonna say the same,
I was what, 20? Is that correct? Yeah, that's correct. I was 20. Yeah, I was 20 at the time. Yeah.
What?
And you saw.
Yeah, he came to visit me.
Oh.
You guys don't know this? Yeah, he came to visit me once. Why do you think I believe? You think this is random?
Oh, wow.
This isn't random.
So yeah.
I'm losing faith in my ability to refute at this point.
Wow, I don't think you need to refute that point, to be honest. I think that we should probably call the debate there. I'm going to.
I would like to ask one more question, actually.
Yeah, go ahead.
What is it?
W, do you know the difference between a silhouette and a shadow?
Oh God, the whole light thing. Oh God, please. Look, I told Casual, I'm like, I'll show it if we debate religion. I told him, I'll go on your channel, we'll have like an hour debate. If I'll show it, you know, I'll explain and I'll show it, and then we'll have a religious debate, because I've been wanting to have a religious debate like Yeah, we have flat Earth debates, which is religious, but God, I want a real religious debate, scripture and everything. But yes, I know the difference. He explained it to me, and I'm just like, I could care less what you call it. I care about what I see. I told you, I care about what I see.
I mean,
And it's really that simple.
Is there any chance that you were, I don't know, dreaming, hallucinating?
I was awake and reading my Bible.
I mean, that's
I was literally awake,
that Bible
reading
is
my
a hell of a
Bible.
drug. Definitely, that Bible is
Okay.
one hell of a drug.
All right.
What a brilliant way
Look, I'm
to
telling
avoid
you.
the question.
Yeah.
What happened?
You brilliantly avoided the question. In
No. What was it?
fantastic Flerf classic. Right. Thank you to both you guys for the debate. If you want to see the first part, I'll make sure the link for it is in the description. I'm going to read the super chats that I've had. And then I think it's time to close down. Possibly might be back in a bit with a debate, myself against somebody. I'm just checking.
Against who?
Some guy that was in the chat.
Doing bullying, it's about to get real.
Okay. Right, let me just refresh that and I'll get my super chats up. Right, £5 from the Casual Spaceman. Why you are an idiot? What's the difference between a shadow and a silhouette? Yeah, I think you just avoided that nicely. And can you prove you can cast a shadow on a light source? Prove it live on my channel. I think Casual Spaceman's challenging you to a debate on his channel.
Yeah, look, I told him what my requirements are. I want to have a religious debate. He said no. So guess what? I told him no then. I won't come. It's really this simple. It's this simple. Just let's have a religious debate. I'll answer the question and show it. And then afterward, we'll have this debate.
Okay. Well, I think you need to speak to Casual Spaceman to get something sorted out. $5 Australian from John Rapp. All this guy can do is cite YouTube and the Bible. Both are his Bibles. How many times has he said it's on a video? Quite a lot. $5 from John Lee Pettimore III. How do I know it's one goss? How do we know it's Jeebus magic? Because he saw God, remember? So, therefore, Jesus magic.
I told you I want to have a religious debate because I can explain the other religions. I understand them now.
NASA instructed Aussie Globehead to donate 50 Aussie dollars. Douche Canoe, how do you prove God did it? $9.99 from Paul Schumann. Why You're an Idiot has suggested his model possibly makes a prediction. Hold his feet to the fire. Put up or shut up time, son. Yeah, I did try asking that, and he dodged it by saying he didn't make a prediction. NASA once again instructed Aussie Globehead to donate 50 Aussie dollars. Derp derp, I want my brain cells back. Well, I was getting really good with that pretending to be human thing. Thanks, Aussie Globehead. $2 from Bubble Burster. Has Why You Are an Idiot presented even one fact for his side yet? No, he has not. $1 from Saxy88, no message, thank you, and another one.
Ooh, that's a good question.
And $5 from Saxy81, my brain hurts, I'm sorry, not sorry. And $2 from Damjan Vizhnovic, I hope I got that right. He's proving evolution. Yes, also natural selection, it would appear. And there's a couple more.
Yeah, from bigger to smaller, yeah, sure.
$2 from Cajun Crustacean. If there's a triangle with sides of 1, 1, and 1, what are the internal angles? W?
What happened?
Oh,
if there's a triangle with sides of 1, 1, and 1, what are the internal angles?
I don't know, 3? I don't know.
That never gets old. And $1 from Faux Hammer. 35. Oh, that's Anthony Riley levels of stupid. It's fantastic.
I'm telling you. Look, I told you guys this already. I'm not a math guy.
I
don't care about math.
There's not a math guy, and then there's not knowing the internal angles.
Sorry, it's just math is just trash now, man. It just is. It's become very trash. The more basic you keep it, the better. The more complicated it gets, the more I throw it away.
All that math that's allowing you to connect from your computer to my computer to YouTube. Yeah, we just ignore all that math. It's trash. Thank you guys.
The technology was created by the watchers. I've already been over this.
All right. It does appear that I will be back in maybe 20 to 25 minutes with another debate. I'm just going to go and grab something to eat and get it set up against 33. He's at 33UC on Twitter. And he says that he has evidence that there's no curvature and no spin. So that should be fun because I have evidence of both. Thank you, everybody, for watching. Thank you, Multiperson3141, and thank you, Why You Are an Idiot, for both the debates, although I will be billing you for my loss of brain cells. So thank you very much for that.
Don't worry, you guys are going to hell anyway, so, you know.
Of course I am.
Yeah, that's how it is.
Hell's a real thing. And
you gotta die eventually, right? You gotta die eventually, right? Yeah, don't worry. You're gonna die. You have to.
Make sure you guys are subscribed and all that lovely stuff. I will see you very soon. Remember, stupidity is not a right. Fight the flat. Fight the flat. Fight the flat. Fight the flat. Fight the flat.